Good afternoon, everyone. Myself, Navroop Kohli. I'm working in Cybersecurity Technology Division of C-DAC Mohali. Today, I'm going to talk about threat hunting. Let me share my screen. So this is about me. And now my topic is cyber threat hunting. So what is a cyber threat hunting? Cyber threat hunting involves a proactive strategy aimed to detect previously undiscovered or persistent threats residing inside the organizational network scenario. Understanding the necessity of threat hunting is crucial in the evolving cyber landscape. To comprehend this, it is essential to first grasp the dynamics of the current cybersecurity landscape. So you must have gone through these advertisements either in newspaper or on the internet. They become a significant concern for every organization embracing digitalization. The Colonial Pipeline is a company that is based in United States. It provides gasoline and other fuel services to various states of US. In the year 2021, their billing infrastructure became the victim of ransomware attack. The billing files were encrypted by the attackers, and the company was not able to generate bills for their customer. Services were halted for 2 days and resumed after they paid the ransom to the attackers. Reason behind this deadly attack was simple. It was a mistake of an employee of that organization. He used identical passwords for VPN connection, and two-factor authentication was also missing to access VPN connection. The password repetition and two-way authentication. These were the key factors for attackers' success. The compromised password that was available on dark web and being used by dark side group of Russia to perform this devastating cyber assault. Hackers remain approximately for 1 month inside Colonial's IT network before launching their ransomware attack. So another one is this PHP package flaw. The PHP package manager flaw left millions of web applications open for various attacks. The vulnerability was found in the composer that used Packagist. Packagist provides online service to manage PHP package request. All the PHP web applications used this composer, not only made the websites vulnerable, but servers also vulnerable on which this composer was installed. After exploiting the vulnerability, attackers were successful to deploy backdoor on the server and to get credential of that server. Now comes this Air India report, data breach. So Air India data breach that leads to loss of 45 lakhs people personal information. Total period for which attackers accessed the system was approximately 1 week to 22 days. After few days only, company came to know about this cyber attack. So these incidents exert pressure on organization to enhance their security methodology and infrastructure. And threat hunting is the main part of this. Most common cyber attacks. So this is the list of slide of most common cyber attacks. So if you will see these statistics, so most common cyber attack experienced by companies are as follow. Like first one is the phishing attack. Phishing is the practice of sending fraudulent communication that appear to come from a reputable source. It is usually done through email. The goal is to steal sensitive data like credit card and login information, or to store malware on the victim machine. It constituted 37% of the total attacks. And second is the network intrusion. A network intrusion is an unlawful intrusion into the digital assets of a business network. By this means, malicious actor try to obtain access to the internal system, and it constitutes 30% of the total attack. Now comes the third one. This is inadvertent disclosure. Means type of incident involving accidental exposure of information to an individual, not authorized to access. It constitutes 12% of the total attacks. And the fourth one is lost or stolen devices. Lost or stolen computing devices leads to major breaches which contributed 10% of the total attacks. And the system misconfiguration, that is incorrect or misconfiguration of the information system that lead to vulnerabilities, it constitutes 4% of the total attacks. And if we see top global fraud types, this phishing, rob mobile apps, brand abuse, that works with the theme of exploiting an existing brand. And if I'll talk Air India case study, which I shown you earlier, that was an example of this brand abuse. And this Trojan horse. Trojan horse are the software that seems to be legitimate, but actually are malicious computer programs. And then third, this shows volume of cybersecurity incident by sector. So we can see here that financial services sector and information and communication technology, these two primary sectors are most severely impacted by cybersecurity incidents. So today, I'm going to discuss about SDN-based threat hunting. Focus on the architecture I designed to detect and mitigate cyber attacks. So what is SDN? SDN stands for Software-Defined Networks, which is a networking architecture that enables the control and management of the network using software applications. In software-defined network, behavior of the entire network and its devices are programmed in a centrally controlled manner through software applications using open APIs. Unlike traditional network, it segregates the data plane with the control plane. Data plane, also called forwarding plan, forwards the packet from source to destination, whereas control plane responsible for how packet should be forwarded. SDN plays important role and will be one of the leading technology in coming years. It provides better network connectivity, better security, provide freedom to create more different zones based on security of devices, better control using open standard software-based control, and all. So integrating threat hunting methodologies with SDN infrastructure offers a novel approach to managing threats spreading within an organizational network scenario. In this scenario, I have integrated the threat hunting framework designed by me and developed by me and my team with SIHA, that is SDN-based intelligent honeynet architecture, designed and developed by me using two technologies, SDN and honeynet. In this new architecture, traffic being initially classified at the SDN, and that is before reaching the destination host, and that malicious traffic being redirected to threat capturing sensor that collect logs and that parse to attack detector, where logs being analyzed and correlated. So these are the modules of SDN-based threat hunting. First one is the traffic classification. In traffic classification, the classification engine which classify the malicious traffic approaching to any system in a network based on some customized rule or heuristic and other means. Second module is the traffic steering. Traffic steering. So, traffic steering. Traffic steering here, I have used SDN controller. In traditional networking devices like router and switches, that uses distributed control plane. Distributed control plane means that control plane of all networking devices lies within the device itself. Each device has their own control plane to control data plane. In centralized control plane system, there is a device which contains control plane of all devices. This device control activities of the data plane of all networking devices simultaneously. This device is called SDN controller. All the traffic flowing in network pass through this controller, which monitors and control the traffic dynamically. So malicious traffic being classified by classification engine based on dynamic rules set and is redirected into the threat capturing sensor deployed in the same network, and legitimate traffic being allowed to reach their destination without any hindrance. Then comes the module 3, log collector. Various softwares running on these threat capturing sensors capture all the logs pertaining to system, network, device driver, or file system changes. Now comes the module 4. This is TTP mapper. TTP mapper here, MITRE attack framework is a globally accessible knowledge base of adversary tactics and technique based on real-world observation. It provides foundation for development of specific threat models in various sectors, that may be a private sector or the government sector. Here, all suspicious or malicious logs being mapped with MITRE TTPs, that is tactics, techniques, and procedures. These logs being sent to the attack detector where various correlation engine running on it correlate it and generate a threat hunting. So now comes the classification and steering of malicious traffic. Traffic classification. As I have already briefed about this, classify the malicious traffic propagating inside the organizational network scenario based on some these heuristics or rule base. When talking about this steering of malicious traffic, do two main components, that is OVS and SDN controller. OVS is open virtual switch. It is an open source, open flow switch that provides network virtualization. All the physical devices are being connected virtually with this virtual switch through an virtual interface. So SDN controller use open flow protocol to control these virtual switches. And now SDN controller whole traffic being handled by programmable SDN controller. It writes customized rules to handle packet intelligently. Classified traffic being redirected to dedicated attack capturing sensors for further analysis without the knowledge of attacker. Attacker used to assume that they are being communicating with their target, their victim machine, but actually they are getting response from these threat capturing sensor. So threat capturing sensor here is a low interaction or high interaction honeypots based upon their configuration and their resource setup. So they collect the system, registry, device driver, networks changes. And binaries are captured using various means, and network traffic, complete network traffic being captured, and logs are stored on a system. So now this log collector. This log collector collects lots of logs. And but I have listed some important one. First is the process create logs. If an attacker has started any process, so it will be logged. Now is the registry key events. All the logs pertaining to registry will be logged here. File being created, network connection. What is the source IP, destination IP, source port, destination port, pipe names being created, and RDP, that is remote desktop protocol logs, where the attacker is trying to make connection with the CNC or bot master using this RDP. .pkf file, the complete logs being captured, binaries or whatever binaries drop, that being captured. So now come TTP mapper. As I have already explained MITRE framework, so it basically contains 14 tactics, and corresponding to these tactics, 270 techniques and their sub-techniques. So it depends upon the attacker's motive, depth, whatever he wants to follow. If we take case of reckonance, there are 10 techniques by which it can perform reckonance. He can gather victim network information. He can gather victim organization information. It depends what is the purpose, what is the motive of the attacker. So based upon that, attacker utilize all these approximately whatever technique he required. So I have mapped these techniques with the with the logs, and I have just designed the structured. I have just designed that structured threat hunting in which I have planned everything. So based upon the logs I am capturing, I have mapped these techniques with that log, so that at the first level of investigation, I would be able to get the picture about that. So now comes the attack detector. Once these mapping has been done, then the whole of the logs from client machine, they are being passed to this server, and where various analysis engines are there. And first of all, these logs being matched with threat feeds, and whether internal threat feeds or external threat feed, as we are getting threat feeds from certain also to get the IOC regarding that attack. So, or to get anything matching to that. Now, we used to see the historical data also, that this was occurred previously also, or it's totally a new thing or a new way the attacker is approaching this attack. Now is the EDR log. So various EDR sensors which are we are viewing that also. We do analysis accordingly also. Now analysis and correlation engine. We are having various analysis engines, static, dynamic. So all these are passed to the based upon their analysis engine, and after that the logs being correlated, and full-fledged report is generated. So cybersecurity analysts view all the information and validated all the attacks or whatever incident. So it basically declare that incident has been happened or it's not been happened. So it is the call of the cybersecurity analyst. After that, if the incident has been happened, then formal report being generated. So this is the simple process of that. Now comes the living of the land boundaries, LOLOWINS. If you see latest attacks, either ransomware or either any attack, Flex Typhoon. So now attackers are not using sophisticated malwares or binaries to perform, to make their system victim and to achieve target. They are using the LOL bins. LOL bins are the binaries of non-malicious nature, local to the operating system, utilized and exploited by cyber criminals and crime group to camouflage their malicious activities. So they use this PowerShell. PowerShell is a normal Windows utility that is basically used to play with the Windows administrative privileges. So attackers are using PowerShell. Suppose if an attacker, he has to create a malicious account in that using net user ad and all. So it will use this PowerShell. So whatever activity that will be done on this PowerShell. So I have written a structure rule that will be mapped with the Mitra ID, so that the flow will be clear that what attacker has done first step, second, and all. Now attackers are also using this CMD simple command line. So if an attacker has to do make RDP connection, they are using this command line. So by this, it seems to be the legitimate one, it's a legitimate process, but actually the target is attacker is using CMD to make RDP connection with some of their bot master, some of their master. And now run DLL32. Run DLL32 being used by attacker to execute their own malicious DLLs. So here attackers are not using hiring or downloading any sophisticated malwares. They are using the internal resources only, which are not legitimate, which are normal system utilities, and to perform their malicious activities. So threat hunt deep dive. So this I have already explained that I used to do structured threat hunting also. For that, I have made a plan. So this is the first level of investigation where based upon the various activities like ransomware attack detection, various activities done by this like distribution phase in which either through phishing or vulnerability exploiting that malware is distributed over the system. So I have mapped that event with Mitre ID. Similarly, infection phase. When it comes to infection phase, then and similarly staging phase. Based upon whatever activity attacker is doing, so these being mapped and the flow will be clear at the end. So, if we see this Chinese flex typhoon detection, this is one of the major group of these Chinese hacker. Their target is basically government organization. And they are not using sophisticated malware. They are using command line tools to access RDP and implementation of VPN connection. And for lateral movement, they are using just Windows remote management and security account manager to get credentials about the system and the systems over the network. So these are very helpful when we are thinking about structure. No doubt, unstructured threat hunting. We start threat hunting when we get triggered that some incident has been happened. In both the case, these things are very useful. Now comes the threat hunting using Shodan. So threat hunting using Shodan, this is very useful if we have to see particular exposed area. What is, first of all, Shodan? Shodan is a powerful search engine, provides special keyword-based searching. Devices connected with internet, location, hostname, ports correspond to these devices. Exposed area, national and international level. So all these information is provided by Shodan. Initially we were having this API also, and we started with API and we get lots of information about that. So these are the some exposed ITSS I have listed. For this, you will get the information about national as well as the global information. Like you want to see open MongoDB instances, you can use the MongoDB authentication. Now, vulnerabilities that are verified by Shodan API, the command is the query is the one dot verified visit. Similarly, if we have to see the open ports of SQL Server, then the query is SQL port 1433. So these are the some queries which we apply on Shodan, and we would be able to get a clear picture of. Suppose if our target is our server, we want to see whether it is exposed one or what is the status of it publicly. Then we use these types of tools. So this is the screenshot I have taken from Shodan, where it is showing the list of the vulnerabilities which are verified by the Shodan and statistics of the which are existing in more. And it also provides the devices where these vulnerabilities are lying. So one or other mean we would be able to get more information about the things. So I hope you understand my lecture and enjoy my lecture. And if you have any query, I'm available on live chat. You can ask me any question over there. I'll definitely reply there. So that's all from my side. Thank you. Okay.